for the data scientist to take advantage of it. So from this quote, it means that the role separation between data engineer and data scientist is important, especially in large organizations that manage large data for analysis. Besides of that, there are some reasons why we need a data engineer. There are various data formats. The second is various data sources, and last is various technologies. I will try to explain one by one of the reason why do we need data engineer. So the first problem is various data format. Data scientists, of course, need data that already prepared by data engineer. So they just have to analyze the data that and data engineer just to collect and prepare the data. But we see in this slide there are so many various data format. There are two types of data format. The first is structured data, and the second is unstructured data. So the interesting fact that is 80% data in our organization is unstructured data, and unstructured data is more difficult to process than structured data. So if you know about example of unstructured data is our video, image, PDF, satellite imagery, so and it needs skills to process the data. Meanwhile, the structured data we already knew about. We have already knew about RDBMS, Relational Database Management System, and if we have data in the form of columns and rows, and it in a structured way, it more easily to process the data. So data engineer will responsible to manage not only structured data, but also unstructured data. So it is a challenge for a data engineer. So the second problem is various data sources. As mentioned before in the first day about data sources in big data era, there are exhaust data, sensoring data, and also digital content. So in this slide depicts the many sources that can be used to increase our insight, and we must process the data very well because if we don't carefully in data processing, when we want to have insight, maybe we don't get anything. There is an example for like sensoring data. There are GPS or from a webcam or sensoring in a car, and there are traditional data source from traditional business system like from a bank or from our organization, public service or private sector, and there are from social media or digital content. The last problem is various technologies. As we know that a data engineer has responsibility to manage data pipeline from collect phase to process phase until the data is ready to analyze by data scientists. So in this picture, we can see that the technology can be categorized based on their function. The first is for storage, mining, analytics, and visualization. And there are examples for each category, such as for storage, we have Hadoop. We have MongoDB2 for unstructured data. For mining, we have a RapidMiner or Elasticsearch. For analytic, we have Spark, R, or Python that we have learned yesterday. And for visualization, we have Tableau Plotly, or maybe if you're familiar with Power BI, we can use that too. So there are various technology that and it is a challenge for a data engineer to choose what is technology that can fit their needs, especially for a data scientist need, from a collect phase until to analysis phase. So we will discuss about difference between data engineer and data scientist. In this picture, we can see that data scientist and data engineering has overlapping responsibility, especially in big data. From the skill aspect, data scientist has core competencies in advanced mathematics, statistics, machine learning or artificial intelligence, and last is advanced analytics. Meanwhile, the data engineer has a core competencies in advanced programming, distributed system, and data pipelines. So we can see this is overlapping skills between data engineer and data scientist. They are from analysis aspect, programming, and big data. So for analysis, however, data scientist analytic skills will be far more advanced than a data engineer analytic skills. A data engineer can do some basic to intermediate level of data analytics, but maybe it will not same with the skill of data scientist. Um, from the programming aspect, both of data scientists and data engineer have programming skills, but uh, you don't. But data scientists can use their programming skills to build a data pipeline, because data pipeline is skills that is needed by a data engineer. And for big data, in big data era, of course, there are issue in big data, because the data is, we must maintain a huge amount of data, and if data scientists do all of the work, I think the data scientists will be collapsed. So data scientists needs a data engineer to assist them in big data utilization. So the challenges is how to determine the ratio between data engineer to data scientist in our organization. In some reference, they state that one data scientist need two until three data engineer. But for a large organization or companies, one data scientist can meet 4 to 5 data engineers. So in this illustration, you can see that data engineer is we need more data engineer in our organization. So this is data engineer skills. This is the main skills that is needed, that must be owned by a data engineer. The first is architecting distributed system. For example of distributed system will be explained by my colleague Hanif. Um, the data engineer must be know about what is the difference between distributed system with the conventional or a traditional storage and processing system. And the second is creating reliable pipelines. About data pipelines, the detailed explanation will be discussed later with my colleague Ita. And for creating reliable pipelines, the main point is maybe when we read or heard about creating reliable pipelines is sound easy or trivial, but at a big data scale, this means bringing together 10 to 30 different big data technologies. And more important is a data engineer must choose which is the technology that can be implemented in organization. The third is combining data sources. For this point, they need to know how to access and process the data, understand how to integrate data from different sources based on metadata. And besides of that, data engineer must do data cleansing, taking out the messy data and make sure that the data is make sure the data is ready to a data scientist. The fourth is architecting data stores. Architecting data store, it means that data stores must be managed based on the characteristic of the data. We already know that data, there are unstructured and structured data, and between both of them, it must be managed differently, and maybe technology to process the data, it will be different. The last is, of course, collaborating with data science teams and building the right solution for them. In here, we can see in the picture that data scientist is more advanced in analytic and machine learning, artificial intelligence, but in data engineer, it more on advanced programming, distributed system, but they have overlapping here, where data scientists prepare the technology that can be used by data scientists to do machine learning, or for optimize the performance of machine learning that has been built by data scientists. Still in data engineer skills topic, the picture illustrates what are popular skills for a data engineer. There are a relation between data engineer skills versus salary. For example, if you have Scala programming skills, it will increase your salary around 70%, 17%, and this illustration show that data engineer have opportunity to get the work, and salary is more high than data scientist. So there are programming language that usually used by data engineers, such as SQL, Python, Spark. They have to know ETL tool and data analysis. But maybe it's not similar with data scientist, because data engineer is have to skills in basic to intermediate level of data science, data analysis. So for the role of data engineer, in this slide, we can see there are three roles of data engineer. The first is generalist, the second is pipeline centric, the last is database centric. For generalist, it is common we find in a small organization. So data engineer will do all the work from manage data to analyzing it. But in mid-sized companies or in larger organization, the roles, it will be spared because the complexity of the data that must be managed by them. So in pipeline-centric, data engineer will be focused on pipeline creating the data pipeline, so it can help data scientists to use the data. And the last is database centric. So beside of prepare the data pipeline, the data engineer have to know about data warehouses, and data warehouses, they have a responsibility to integrate the data from many sources, so it can be used for analytic. It ain't easy for becoming a data engineer because if we see there are many responsibility in here. They have to develop, construct, test, and maintain architecture. And of course, the architecture they have developed must be aligned with business requirement. And they have to do data acquisition using the architecture that have been developed. And beside of data acquisition, they have do pre-processing to the data, do data cleansing or data manipulation, and make sure that data is ready for a data scientist. And for data collection and data processing, they will use programming language and tools, and they must identify ways to improve data reliability, efficiency, and quality. And before they collect the data, they have to do or conduct research for industry and business question to know about what is a business issue that will be solved with the data that will be collected. And so use large data set to address a business issue. Yes, in big data era, maybe uh, we have to collect the data from many sources, not only one sources. So because the business issue is related with many aspects. And the next is deploy sophisticated analytic program, machine learning, and statistical method. But I think in this point, it may be different with data scientists because the advanced analytic will be a responsibility of data scientists. And prepare data, of course. Prepare data for predictive and prescriptive modeling that will be implemented by a data scientist, and find hidden pattern using data because if we use machine learning, we have to collect much data and have training data and learn about the pattern of the data. And the next is use data to discover tasks that can be automated. So from data that data engineer has been collected, they must find a way how the data can be helped in automatization process. And the last is deliver updates to stakeholder based on analytics. So besides of the technical skills, the data engineer must have soft skills to communication what they have been found in the data to a stakeholder or business user. So after we know about the roles and the responsibility, this is a challenge in data engineer. So the first is data engineers must learn on their feet. Because data engineer is a discipline data engineer is a discipline that is dynamic, and maybe we can find the course that especially for data engineering that we must study from many sources based on internet or references how to create a data pipeline, learn about various technology, because if we don't try to learn by ourselves, so we can meet the needs of organization, especially for data engineers responsibility. The second is too much data to handle. Of course, if we talk about big data, it's too much data, and it will be challenges for data engineers to manage all of the data that have been collected. The peer performance, maybe so many requirement from business and many and so much data to and to be collected by a data engineer, and our environment or our hardware is not sufficient. It doesn't have a good performance to handle all of that. So it will be challenges for data engineers to determine whether we still use our environment or on-premise. Usually we use on-premise technology or solution in our organization, or we must moving to cloud technology, because if you use a cloud technology, we don't have to worry about the performance, and we just have to use the technology that have been prepared by the provider. The fourth is data pipeline maintenance. Yes, data engineer must, beside build the data pipeline, they make sure the data pipeline is working in order and can get to the data, because we know the one issue in big data is how to access the data, because not all the data is can be accessed freely, but must be using MOU with the data provider. And data governance. Data governance actually is not fun, because there are so many bureaucracy related with data governance. But if you want to have a high quality of data, you must consider about data governance. And the human element, because maybe there are challenges in there are challenges that is faced by a data engineer related with the human. So not only technology, but the human can be a challenge for data engineering. So the next is unclear strategy, because we know that um, in big data era, they are the term of machine learning, artificial intelligence, but we must consider what is the aim when we use the technology or the machine learning, and what is the impact for us. So we have a clear strategy. The first, we must have a clear strategy to adopt some some new technology, because the the unclear strategy can affect to our organization. And the last is resistance to change, because if we are a data engineering, we are a data engineer, and we have to learn so much technology, and maybe uh, our uh, our college in our organization have feel comfort with legacy system, so we must have to buy in the part of our organization to use a new technology that the data engineer have been prepared. So this is the example of data engineering. Generally, it will be started with a specified need, when the data engineer and data scientists do discussion about what is the needs, analysis needs, and turning the needs to a requirement. And the requirement in design phase will be turned in a logic for data collection and data processing. And from the design will be built a solution for data collection, data processing, and data analysis. In the build, we will prepare the technology itself, and for collect phase, we will use the technology that have been prepared in build phase. There are, maybe we use web crawling, or ETL tools for collect the data, or we utilize the API from external system. And for process, there are the main point is data cleansing, data transformation, data integration, because all of the resource, all of the data that have been collected, maybe data scientists can do analysis, can analyze the data directly. We must first cleanse the data, transform the data, and integrate the data. And if the data ready, have been ready for data scientists, it will use in analysis phase. So this is the example when we have the step in data engineering, we have to choose technology. And in each of space, maybe it will use different technology. For example, for data collection, maybe we use Python for crawling from marketplace website. And for data staging, we use SQL Server for start the data that have been collected from data crawling process. And to start in Hadoop, we use a process, namely extract, load, and transform, because in Hadoop, we can store the data in its native format. So we can use a scope service from Hadoop distribution to store the data from data staging to our single source repository. And for processing and analysis, we can utilize Hive and Spark engine that have been, the Hive and Spark engine are engine processing that have been installed in Hadoop distribution. And for structure of our needs of data scientists, maybe we can use extract, transfer, load process to store data that have been processed in Hadoop and store it in SQL Server for data warehouse. And for analysis service, because it will be a performance issue if we visualize the data, big data directly. So we need analysis service in here. So our analysis tools, such as Power BI, will be connected to analysis service and display the dashboard that based on our requirement. So I think it is what is a data engineering topic already finished. And maybe we will continue to data modeling topic, that before I continue discussion, maybe is there any question about the material? If not, maybe I will continue to data modeling topic, because it is a 3 day. So after we discuss about what is data engineering, the roles and responsibility of a data engineer, we will talk about what is data modeling. So data modeling is the process of creating a data model for data to be stored in database. Maybe any of us is already familiar with a database, and usually we make or create a database, and the table we need directly to database technology. But actually, before we do the implementation, we need data modeling, because it will help us to communicate our design of a data model to business side in our organization. Because if we show the database, I think the business side will not understand about the database. But if we show the data modeling, maybe we can do a discussion more with them, and we can find what is the requirement that have to meet using our data modeling. So in this slide, we can see that data modeling will help us in the visual representation of data and enforce business rules. So in data modeling, we we are not just do design of the table, but also business rule that must be implemented in our database. And data model. So a data model is defined as abstract model that organize data description, data semantics, and consistency constraint of the data. In the right side, we can see the diagram. There are a process, logical data modeling, physical data modeling, and last is create or update data. And this is the input, and this is the output, and can be the input for the next process. So for a logical data modeling process, we need input in the form of process model and data requirement. From process model and data requirement, we will have the output from logical data modeling, that is a logical data model. So process model, maybe we ask the business about their requirement and what is the main process that they want to handle in our system. Maybe they are process to register the member, or order menu, or payment, that will be thrown in a process model. And data requirement related with what is the data that is already known by a business side. Maybe in if you have a process model to for example, payment, the data requirement is about the date of the payment, the number of payment. So there is a data requirement. All of that will be used in logical data modeling, and it will produce logical data model. And the second process is physical data modeling. It is the process where we start to implement the logical data modeling, and we add the technical requirement and performance requirement. In physical data modeling, we will define what is the type of our table column. Maybe for a name, we use a varchar, not integer, like that. So it is the illustration is like that. And the input and the output from physical data modeling is physical data models. And after we implement the physical data model, so we have a database, and the database consists of some tables, and in one table maybe consists of some attribute, and it is used. And if we in operational, there are business data from users of the system. So user of the system will be maybe insert or update the data, and finally we have data. Data have been updated by a user of the system. So this is the illustration of conceptual data model. If we talk about conceptual data model, actually we will have the entity such as customer, transaction, and product, and each of entity have attribute such as customer name, customer address, number, date, and for product they are product name and product price. And between entity, they have a relation. For example, customer, maybe a customer has a transaction, and we can determine what is the cardinality of the relationship. Maybe it's one customer, has one or more transactions. So we can set here a customer has relation one to many transactions. So conceptual model, the example is like this, and it just discuss about what is a business requirement. So if we in gathering requirement process, maybe we just ask about what is the main entity in our business process and what is the information that have been provided by each of the entity. So in logical data model, if we look at the conceptual model, there are difference between them. In logical data model, we already define the type of the column, and maybe we already consider about what is the unique key that can be implement in each of entity. For example, product, we add a product ID uh, as a unique key, and the type is integer. Similar with the other entity, we define the type and type of attribute and what is key, unique key for each of attribute, each of entity. Oh yeah. The in addition, in logical data model, maybe have to we have to do a normalization because maybe in some cases we find that they are must be spared between a table. If we do normalization, maybe one table can divide it into two parts. Maybe one is transaction, and we can add one master again in this logical data model. So in logical data modeling, we have to consider the normalization of the scam. Because if we talk about OLTP, online transaction processing, the normalization is very important for data integrity. And the last is physical data model. It is time to implement our model to database. In here, we can see we already determine which is a primary key and which is a foreign key for each of attribute. And we have a type of column that is depend on database technology that will be used. So maybe it is the advantage of data modeling. The first is reduce errors in software and database development. The second is, of course, increase consistency because we already designed the system and it can be used to confirmation with the business. And whether our design already meet their requirement. And the third is improve application and database performance, because if we choose a type of column, we must think about the consequence of type of column. For example, if we choose to use integer, there is a risk if the data is have a continue value like 1.5. If we use integer, it is just 1 or 2 because the round up of the value. So we must consider about that. The fourth is data mapping throughout the organization. The fifth is improve communication, of course, with developer and business intelligence teams. And the last is and speed the process of database design. The last about data modeling is case, because as I said before, if we have to show the business team our conceptual data model, maybe it is difficult to communicate the conceptual data model with them. So we can add one diagram in here that is business use case. And in this business use case, we can see there are entities, same with conceptual data model, the entity of the business process, there are sellers, customer, mill manager, service representative, and what is the process that related with each of entity. For example, sellers, they will do send proposal, open account, and service representative will do expand this order. And all of the entity that is state in business use case will be, we will move to conceptual data model, like they are customer, they are for service representative, maybe we can say it employee, consists of service representative and sales. So for mill manager, it will be in employee entity. And what is the process? We can the process can we make entity tool such as the order, and account, open account for open account process. So we will create a conceptual data model based on business use case. So, and it will be more easy for us and for a business team to understand what our design. I think for data modeling is enough. And the next material is about data storage and will be presented by Hanif. And for the two topic, maybe if you have a question, you can ask me directly, or you can just type in a chat box. And for remember the participant that we will have a quiz today, and I hope you focus on the listen. Thank you. So back, it will be break or back to Rian.
Thank you very much. I'm not sure, since we have to finish before the 11:45. So should we take a break? Maybe just 5 minutes, then we can start again. So we will start the meeting again maybe in 9:05 p.m. Okay. Thank you. Thank you. It's already 9:05 EM, so I think we can start continue the training again. The floor is for BPS Indonesia, please. Thank you very much. Mr. Han, I think the microphone is on.
Okay. Good morning, everybody.
Yeah. Good morning.
Okay.
Good morning.
Okay. Let me share the screen. Wait a minute. Okay. Okay. Q&A. Okay. Yeah. Good morning, everyone. Thank you.
Morning.
Thank you all for finding time and attending this workshop. And thanks to ASEAN Start to let me participate as one of the keynote speaker for today. Firstly, let me introduce myself. My name is Muhammad Hanif Wayananto, and I am a data engineer at BPS. And you can call me Hanif. Okay, let me see data storage. Yeah, last week when I was going around the city, I passed by several libraries and I start to wonder how if those public service is closed several months at start of pandemic, people will lose access to collection of books, especially the book that not available in the internet. Then how they can get it? Will they ask one by one to their friends or tweet it or post it to Instagram or Facebook or etc. Then I realized that the role of library as place where book is collected, managed, sorted, and classified is quite important. Then I see the role of library is same as database. Yeah, the database is an organized collection of structured data to make it easily accessible, manageable, and updated. In another words, database is a place where the data is stored, data is managed, and data is can be manipulated easily. And if we recall to my story, a library is consists of collection of books. Some librarian, the shelf, the building, the library catalog, and some rules such as how to borrow, bring back the books, or reading at the place, and many more things. It is same as database. There are several components in database, such as the hardware, the software, the data, the procedure, and the database access language. Okay, for the first component of database, we already know it is about the hardware. It is about the physical electronic device such as computers, storage device, input-output device, and many more. The hardware also offer an interface between computers and real-world system. The second is the software. The software is the set of programs that are used to manage and control the overall database. It also includes the database management system, the operating system, and then the network software, and the last one, the application program that uses to access the data, maybe the client program or the server program that connect to the DBMS. Okay, for the third one is the data. Okay, make it simple. Is the data is a raw and unorganized fact that is required to be processed to make it meaningful. It can consist of fact, observation, perception, numbers, characters, and many more. And the DBMS collects, stores, process, and access the data. And don't forget the database also holds both the actual or operational data and the metadata. So two kind of data that held by the database. And for the fourth one, the procedure. The procedure are the rules and a set of instructions on how to use the database. It is designing and running the database using documented method which to guide the user who operate and manage. And for the last one, the database access language, or we can call DAL. DAL is used to access the data to and from the database, enter new data to database, for updating existing data in database, retrieving required data from database. User of database can write some specific comments in DAL, and then the user must submit it to the database. So the database will process it and generate it into user readable form. So we already know 5 components of database: the hardware, the software, the data, the procedure, and the database access language. Okay, we can continue for the next part. Wait a minute. Before I continue this explanation, how many database have we seen so far? Is it only relational database or NoSQL or any more? Okay, here we go. We can see there are more than 2 types for database. There are relational database, NoSQL database, centralized database, distributed, cloud, OODB, graph, warehouse network, and hierarchical.
Hello, I couldn't hear your voice, Mr. Hanif.
Oh, hello. I'm sorry, there are some technical difficulty with the
Yeah, I think you
network.
should repeat then.
Yeah, yeah.
Oh, which slide? This is the last slide. Database type or okay, I will repeat again. Uh, there are several database type today. There are such as relational database, not and NoSQL database, centralized, distributed, cloud, OODB, graph, warehouse, network, and hierarchical. And then, okay, here we go. Mm, the first one, we already know the first type of database is relational DB. Relational database uh, is a database that use structure that allow user to recognize and obtain data in relation to another piece of the database, piece of data in the database. So the key is its structure and the form is tabular and have relation. Okay, for the second point, uh, data in relational database are organized into tables. That's tabular data. And surprisingly, relational database have been an important part of modern computing since 1970. So it's not the new approach, but it's have already in there, 1970. And in the slide, we can see there are so many product of relational database or some database management systems such as Postgre, MySQL, Oracle Database, SQL Server, IBM DB2, and SQLite, and many more. I can tell a lot of relational database today. Okay, for second one, is it NoSQL DB? Don't you know if NoSQL DB is stand for not only SQL, or maybe we have ever think if it's not SQL, but in reality it's not only. Okay. Wait. I'm sorry. The NoSQL is an approach to design such database that can accommodate a wide variety of data model. So with NoSQL DB, we can get some benefit. The first one is it's useful for a large set of distributed data, and most of them are open source. Yes, all DBMS of NoSQL is open source. The second one, it is schema-free, non-relational, and flexible DB for use for big data and real-time web apps. So we don't need to think so deeply about the relational. It's stable and it's free to design the schema. At current time, we can schema A, and then at next time or next month, we can evolve. I'm sorry. We can change the schema become B because there are new attribute. Okay, back to the benefit. The third one, with NoSQL DB, there is high scalability and high availability. And for the last one, NoSQL DB is very efficient in analyzing large size unstructured data. Okay, this is enough for NoSQL DB explanation. Then I can move to the type of NoSQL DB. There are 4 categories of NoSQL DB. For the first one is document database, where it pairs its key with a complex data structure known as document. It can contain many different key value pairs or key array pairs or even nested documents. You can see at the slide, there are some documents which connected with its other document. And we can see there are Clouden, CostDB, Apache CostDB, and MongoDB, which are the DBMS for NoSQL DB document database. And then for the second one, there is key value stores. Key value stores is the simplest NoSQL database. Each item in the database is stored as an attribute name or key together with its value. You can see the picture how to describe it in the slide in the bottom part. Its key is connected with the value. As simple as that. And if we want to know the implementation of key value stores, we can try the memcached database or codes-based server, Redis, or Oracle Coherence. In this section, I'm sorry, codes-based server and CostDB. Wait a minute, I will show the laser point. The codes-based and the MongoDB. The codes-based server and CostDB, it's two different NoSQL DB. Sometimes we confuse to distinguish between two of them. So they are Apache DB in document database and the Postgres server in key value stores. And next, the third type is graph store. They are used to store information about networks. We already know the graph type from Neo4j and HyperGraph DB. There are many implementations from both of them. And for the last one is wide column stores type. The wide column stores are optimized for queries over large dataset and store columns of data together instead of rows. So it is the opposite thing of general approach of relational database, which is rows oriented. So the wide column store is column oriented. And we can see the implementation of wide column store of NoSQL DB is such as Cassandra, Apache XBits, Cumulo, and Google Bigtable. Google Bigtable is available in Google Cloud Computing. Yes, there are the four type of NoSQL DB, from document to the key value to graph store, and then the last one, wide column stores. Okay, we continue to the centralized DB. We can see from the name if it's stored. Sorry. You can see from the name if centralized DB is stored at a single location. Yes, a single location where many clients access to single repository. Because it's centralized, it is maintained and modified from that location only. And the basic usage of the relational DB is centralized. I'm sorry. The basic usage of relational DB is centralized DB. This is not surprisingly. So we can see the MySQL, if we develop at one location and many clients access it, it can call centralized DB, or maybe SQL Server at one location, or Postgre and any more. Next is distributed database. And yes, we can guess from the name, it is the opposite of the centralized DB. It is a collection of multiple interconnected databases which are spread physically across various locations that communicate via a computer network. From this one, so there are at least two locations which interconnected. In this concept, in distributed database, the data is divided become some fragment, and each fragment can be saved at once or more than once computer. So we can say the replication, it can be happen in distributed database, or it cannot be happen. It depends on the plan. And then its location of distributed database is under control of its database. And one of the advantages from distributed database is each user do operation based on location. So from client in here, client A in the bottom part of left bottom part don't need to access database in top database, because the client A, the data is near with the bottom database. Next one is the cloud database. Cloud database is one of the features of cloud computing, and don't, and is it not and it is not a new approach because it has been implemented before 2000, 2010, where when web hosting become available. So is it not a new something new, but it's already there. And then in CloudDB, it is optimized built for such virtualized environments such as hybrid cloud, public or private cloud. It can pay for storage capacity and bandwidth. It offers scalability on demand along with high HA. No need maintain the hardware or software. So we just use it and do anything in the cloud DB. And then it has advantage for business organization where it supports business application in software as a service. So the organization just do it the business thing. Don't So organization don't need to think about the cost of hardware or cost of software or the architecture of database. And we can see there are several cloud DB today, such as AWS service, Azure, and Google Cloud. AWS like AWS have Amazon DynamoDB and Amazon RDS, which wait a minute, Amazon RDS, which is Amazon RDS. There are several RDBMS such as MySQL, MySQL, SQL Server, Postgre, and more. And then we can choose the Azure service, where there are SQL Server Cloud, and there is Azure Cosmos DB, which is for NoSQL DB. So the NoSQL DB in Azure is Azure Cosmos DB. And for the last one is Google Cloud. And in the Google Cloud, there are Google Cloud SQL, Google Cloud Bigtable, and the last one is data store. Next, the another DB model is object-oriented database. From the name, we can see if the data is stored in the form of objects and classes. So the objects are the real-world entity, and the types are the collection of objects. It is a hybrid form of relational model features with OO principle. We can see from the picture beside in the slide. So the OODB combine between ACID and OO principles such as objects, classes, inheritance, polymorphism, encapsulation. And one of RDBMS that implement OODB is Postgre. I don't know if MySQL or SQL Server is support the object oriented, but as I know, PostgreSQL is support this type OODB. And then we can continue to GraphDB. The GraphDB is used graph theory to store, to map, and query relationships. We can see from the picture in here. This kind of computer database are mostly used for analyzing interconnection. And in the GraphDB, we already know there is RDF. And for the sample of GraphDB, there are Neo4j, ArangoDB, dgraphs, OrangeDB, and don't forget about SQL Server. But the SQL Server is from SQL Server 2017 and then SQL Server 2019. For the previous version is not support the GrabDB. Okay. And next is the warehouse DB. The warehouse DB we already know is a concept to support BI purpose. It is to facilitate a single version of truth for a company for decision making and forecasting. It contains historical and commutative data from single or multiple sources. And the data warehouse concept simplifies the reporting and analyzing process of the organization. We can say warehouse DB characteristic is there are fact table and dimension table. Okay. The next is network DB. It is the earlier database that have been developed since 1960, and it has been developed by Honeywell and called as Integrated Data Store. Network database it supports many-to-many relation and results in complex database. And maybe it had some limitation like system complexity and difficult to design and maintain. And for the last one for network DB, last DBMS of network DB, as I know, is RDM server. It stands for RIMA Database Management Server. I don't know any product of network DB, but as long as I know, there is RIMA. And the last type of database is hierarchical. Hierarchical is revolved around 1998 till 1980 and well known by IBM first database management system as Information Management System (EMS). In this model, files are related in a parent or child manner. And another example of hierarchical is the Windows registry used in Windows XP is hierarchical database. And same as network DB, there are some limitations like complex implementation, like structural independence, can easily handle a many-to-many relationship. So, because some limitation of network DB and hierarchical DB, the relational DB is created. So, relational DB is not come first, but the network DB and hierarchical first. Okay, after we know the history of all database type, we continue with database operation. There are 4 basic operations in database. There are create, read, update, and delete. We can do basic operation to database objects such as database, table, records, fields, index, queue, key, and view. As example is we can read database, we can read table, or update the records, or update the fields, or we can delete the index, or we can delete the table. Next one. After we know some database type and database operation, let us know the software that manages database. It is called database management system. It basically serves as an interface between the database and its end user or program, allowing user to load, retrieve, update, and manage how the information is organized and optimized. And then, next point, The DBMS also facilitates oversight and control of databases, enabling a variety of administrative operations such as performance monitoring, tuning, and backup recovery. So there are many features in single database management system. As surprisingly, it had been implemented since 1916. And DBMS for relational database is called RDBMS. Okay, next, let us see how DBMS implemented or the architecture. In the picture, we can see there are three types of DBMS architecture. DBMS architecture depends upon how users are connected to database to get their request done. Okay, for the explanation, we can continue to the next slide. So the first one is first tier, where the user connect directly to database system. So anything done here will directly to be done on database itself. It doesn't provide any tools for end user. It is used for development of the local application where programmers can communicate directly to database for the quick response. So user directly connect to database system. For the second one, oh wait a minute. There is database. There is two tier. What is two tier? Two tier is same as basic client server. The client needs an application for communicate directly to database server. We can call the communication via APIs such as ODBC, DDBC, and many more. The user interface and application programs are run on the client side, the bottom one, and the server side provide the functionality of database. Okay, for the third one, there is the three tier. Three tier, three tier, there are two parts, the server part and the client part, where there is another layer between client server and the database server. The client application need to interact with server application to communicate with database system. So we can see in the picture, the client application first must communicate with server application before connect to database system. It's different from two tier, where the application communicate directly. And in this tier, the three tier, the end user has no idea about the existence of database beyond the application server. And the database also has no idea about any other user beyond the application. Okay, that is for the DBMS architecture. Next one, we move to database schema and instance. Instance is data that store in database at particular moment of time. But the schema is skeleton structure of database, or we can say is overall design of database. The schema is present logical view of entire database. A schema can contain schema objects like table, foreign key, primary key, views, and many more. And the schema can be represented by using visual diagram, and we call ERD, Entity Relationship Diagram, which show the database object and relationship, ERD. The schema is designed by database designer to help programmer whose software will interact with it, and the process is called data modeling. So we have been studying about data modeling from the first part in this morning with Mrs. Novi. After we know the schema and instance of database, we move to language of database. There are 4 types generally of database language, such as DDL, database definition language, DML, data manipulation language, DCL, data control language, and TCL, transaction control language. For the first one, DDL is used to define database structure or pattern, and is used to store the information of metadata, such as number of table and schema, the names, index, and many more. From the slide, we can see several commands such as create, alter, drop, comment, rename, and truncate. We can apply 6 of the commands to database or table or records, fields, index, or QA and view. It means we can create the table, we can alter the record, or drop the fields, and many more. Next, we move to the second one, the DML, data manipulation language. For easiness, DML is related to table content itself. It is used for accessing and manipulating data in the database. It handles user requests. We can see the several commands of DML. DML is select, insert, update, delete, match, expand plan, log tables, and call. Call procedure. And for the DCL, the third one, data control language. It is used to retrieve the stored or saved data. And the DCL execution is transactional. It also has rollback parameters. And there are only 2 type commands in DCL. The first one is grant, and the second one is revoke. The grant is allow user access privilege to the database, and the revoke is the opposite thing of grant. Okay, for the last one is the transaction control language, TCL. TCL is used to run the change made by the DML statement. TCL can be grouped into a logical transaction. There are only 2 commands, such as commit and rollback. Commit is used to save the transaction on the database, and the rollback is the opposite thing of commit. So rollback is restore the database to original since the last commit. Okay. The last of the database, but not the least, is asset properties. A DBMS should remain integrated when any changes are done in it. It is because of the integrity of the data is affected. The whole data will get disturbed and corrupted. So, integrated that integrity is the is so very important in database. If not keep, it will be broken and disturbed. Therefore, to maintain the integrity of the data, there are 4 properties in the BMS called ACID properties: atomicity, consistency, isolation, and durability. Okay, for the atomicity, the data remains atomic if any operation is performed on the data. Either it should be performed or executed completely or should not be executed at all. It means don't execute it at all operation or do all operation. Don't do partially or break in between. It's simple as that. It's that for atomicity. And next one is consistency. from the name, we can guess is the value should remain preserved always. If a change in the database is made, it should be remain preserved always. So the database must be consistent before and after the transaction. For the third one, isolation. It can simplicity we can say is it about each other operation not affected each other. So where no data should affect the other one. It means the first operation must be done before the second one executed. That is isolation. And for the last one, the durability. The durability is ensure that the data after the successful execution of the operation becomes permanent in the database. Even system file or relate to crash, the database still survive. So it means if we ever update the database to a new value, and then there is something happen to database, maybe it's crash or another failure, the value in there is the new value, not the old value. That is the durability. Okay. Before we go to the next section, there are several next concepts in database that are quite important, such as data modeling, relational data model, normalization, transaction processing and concurrency control, file organization, indexing, and data backup and recovery. Maybe if we have time enough, I will explain some of them at second session. Okay. Now, let me see the current case evolution of data storage. Let us imagine if we can put our data, which so very differs from RDBMS, from spreadsheet, CSV, PDF, picture, sound, movie file, and several data from internet into a storage, a large storage, where we can process or analyze any kind in that data. Yes, that storage is called data lake. In the data lake, it is a storage repository that can store large amount of structured, semi-structured, and unstructured data. It is a place to store every type of data in its native format with no fixed limit on account size or file. And it offers high data quantity to increase analytic performance and native integration. So, from 3 points above, data lake is used to data scientists, and the data in here is cold data mostly, not the hot data, or we can call transactional data. Why must cold data in data lake? Because we want to dive to analyze the data, not to update, not to delete, or not to insert periodically. So the whole data is ingested to data lake. Okay, in this slide, there are several reasons to use data lake. First one is because the increase in data volume, data quality, and metadata, the quality of analysis also increases. So we can go deep analysis rather than general using of warehouse. And then for the second one, data lake offer business agility. This one of the success key of many recent organizations. If the business, maybe if an organization have no agile, the organization will lose its excellence and relevance because agility is the ability of an organization to rapidly adapt to market and environmental change. And how to they deliver the product in cost-effective ways. So the agility is a important thing for today. The third reason is machine learning and AI can be used to make profitable prediction. And the fourth one is it offer a competitive advantage to the implementing organization. And for the last one reason, yes, there is no data silo structure in data lake because it's schema free, schema reading. Data lakes give 360, 360 degrees view of customer and makes analysis more robust rather than the data warehouse. And then there are several key concepts in data lake, from data ingestion, data storage, data governance, security, data quality, data discovery, data auditing, data lineage, data exploration, and teamwork. For data ingestion, it means we ingested we ingest the data into data lake from any source. Data ingestion supports all types of data, from structured, semi-structured, and unstructured data. And data ingestion must be support multiple ingestion like batch type, rel type, and one type load. And of course, the data ingestion can support many data sources like database, web servers, email, Internet of Things, and FTP, and many more. Then we continue to data storage. The data storage should be scalable, offer cost-effective storage, and allow fast access to data exploration. That is characteristic data storage of data lake. Scalable, offer cost-effective, and allow fast access. And don't forget, it should support various data format. And then for the next thing is data governance. It is one of most important thing in data lake that determine data quality. The data governance is process of managing availability, usability, security, and integrity of data used in an organization. And then for the fourth point is the security. And is it about authorization, user, about authentication, accounting, authorization, and data protection. That are some important features of data lake security. And then for the next thing is data quality. This is an essential component of data lake architecture. If we extracting insight from poor quality data, it will lead to poor quality insight. So we must ensure the data quality is high, so we can get good result of data insight. The next one is data discovery. This is the step before we begin preparing data or analysis. And then data auditing. There are two things on data auditing, where first is tracking change to important data sets, and then the capture how or when or who changed to these elements. Data auditing help to evaluate risk and compliance. And then we move to data lineage. Data lineage is deal with data origin. It mainly deals with where it moved over time and what happens to it. So it records the initial data, the data output, and then the process from data initial until become data output. It's called data lineage. It eases error correction in a data analytic process from origin to destination. And then we go to data exploration. After we know data discovery, we must know to the data exploration. This is the step after we do data discovery, but this is stage before we do data analysis. So data discovery first, and then data exploration, and then analysis the data. In data exploration, it helps to identify a rec data set is vital before starting data exploration. And for the last one, yes, we need teamwork. We need teamwork for all given components together to play an important part in the data lake building, easily evolve and explore the environment. Next one is, this is the picture. What the effect if we don't care about data quality and governance? If we don't care about data quality and the governance, the data lake will become data swamp, where there are a lot of unused data, or simply we call there are many threads. So we must concern about data quality and governance. Data governance is data lake. This is an example of data lake technology. There are several layers in data lake in here. First one is governance integration, the tools. The third one, security, the operation, and data access. And then in this sample, we see there are several things like HDF, SDFS, yarn, and some tools for analysis such as Zeppelin. And for the data access, there are some uh, some some application tools such as Hive, HBase, Accumulo, Storm, and Spark, and Solar. And for the governance, there are some technologies such as Atlas or Farcon. And for the workflow, there are some technologies such as Scoop, Plum, Kafka, and etc. And for the security, there are several tools like Ranger, Knox, and HDFS encryption. And for the operation, there are several technologies such as Ambari, CloudBrick, Zookeeper. And for the scheduling, we have OZ. This is I can say this blueprint of Hortonworks data platform, or for recent today is one of the product of Cloudera, because the Hortonworks is merged with Cloudera. And for the last one, this is several difference between data lake and data warehouse. There are some important thing. We can see that data lake is stored not only tabular form. Second one, the data are mainly unprocessed, because the data which ingested to data lake is from any kind source. So we must to process it later. It's different with data warehouse, which highly processed data. And then for the tasks, the data lake shares data state worksheet. And for the agility, data lake offer high agile, configure and reconfigure as needed. And the user of data lake is mainly data scientist, different from data warehouse, is for business professional. And then for the storage, it's designed for low-cost storage. And one of the most important, the schema of data lake is schema on reading, not schema on writing. Because in the data warehouse, we must need to define the schema first before we load the data. But in the data lake, we load the data first, and then we can define schema, what schema we choose for specific analysis. And then For the tools, we all already know the data warehouse mostly commercial tools, but for the data lakes, sometimes a lot of open source like Hadoop, MapReduce, Spark, Hubase, Hive, and any more. Yes, that's all my explanation about database and data lakes. If there are any ideas or knowledge that can be shared, we are very glad to hear that. Or if any question about this, you are welcome. Is there any question or any ideas from anyone?
Yes, I think Brunei.
Yes.
Us, Mr. Hanif.
Oh,
Mr. Hairul, please, Mr. Hairul.
welcome. Okay. Okay. Oh, hello, Hairul from Brunei. Oh, okay. There is.
Mr. Hanif, you can
Yes.
see it chat room, right?
Yes. Yes.
The question is there. Yeah, thank you.
Okay. I will repeat the question from Hairul. We're from Brunei. Okay. Is it about some database type here? Would the compatibility issues can be solved normally, like for Windows using this and all? Hmm, okay. First, the database type is designed to can work at some platform. Okay. Take a sample. We can see a relational database for SQL Server. For SQL Server, it at the previous version, SQL Server earlier than 2017, it can only be run on Windows. But today's SQL Server can be run in Windows or Linux. So it gives more easiness for user to implement SQL Server in Linux. And for another example, there are no difficulty to apply specific database to any platform. Maybe I can give sample. We want to apply NoSQL DB. Okay, I will go to the slide. We can implement NoSQL DB such as MongoDB in Windows or in the Linux or another platform. It depends on compatibility of the DB. But if we find the database is not compatible, we can choose another alternative that that apa that compatible. Maybe like Redis is not compatible with Windows, we can choose the Memcached or Oracle Coherence, just like that. So if a database is not compatible with a platform, we can choose another product with same type which support the compatibility. Sorry. Yes. What about it, Hairul? Any response or any question again?
Thank you for that.
Yes. Maybe anyone can share the implementation or any ideas about how to support big data that with this data storage so, material. Is there anyone?
Yeah, Mr. Hanif,
Yes.
I'm interested in your last slide on the comparison between
Okay.
data warehouse and data lake. Yeah.
Yes.
Uh, in many simple thing that data warehouse is easier than data lake. Is it right?
For generally, it is yes.
Yeah, and usually people are having data where not people, organization or
Yeah.
institution have a data warehouse first, then update it to data lake. Is it right? The logical thinking like that?
Maybe we can say it is right, but this, the term is not next, but it evolves, expand because data lake is we can I'm sorry, because the data lake can be the source of warehouse.
Or data warehouse can be part of data lake. Is it right?
Not no, it's not like that. In BPS, we can in BPS yes, in BPS the scenario, the source of data warehouse is from our enterprise data lake. We call it enterprise data lake. In the EDL, enterprise data lake, we do some processing, some analyzing, and then we prepare the data set that will be ETL. ETL is extract from load to the data warehouse. So in the data warehouse is already predefined the data, and then the data is give sorry, in the warehouse user is given easiness to create the cube or another thing in the warehouse.
Yeah, actually, my question is related to what you have explained. We will have the second training and the third training, and related with this, is there a general explanation on this, the whole training? For example, if I related with this, and then the data modeling and others, and if BPS could share what BPS have in the case of what are their data modeling, and do they have already a data lake and data warehouse? If you have a slide or for that, maybe this is useful for other countries, or other countries can also share their system with this. If it cannot be at this time, I think probably in the second training or the third training. I think it will be useful.
Okay, maybe in the second part of the introduction data storage, we will give the whole this blueprint, yes, the blueprint of relation between our enterprise data lake and our data warehouse.
Okay, maybe I add the answer from Hanif. In BPS itself, the implementation of data lake is still new, and because most of our data sources is stored in RDBMS, and it in the form of OLTP, because we start data collection data that has been collected in the field to RDBMS. And for data lake implementation, all of the data source from working, we call it a working database, will be stored in data lake. And in data lake, maybe the data is still in its native format. So we don't have to standardize the classification or the master data. But if we want to put the data in data lakes to data warehouse, we must do that because in data warehouse, we know that data already in structured way, they have a standard in classification, in data master reference. So data engineer will be do some transformation in data lake, will standardize the classification between many data sources, because if we remember, we have many survey in BPS, and maybe they use different classification, but in general they have a same concept and definition. And in data lake, we must we must determine what is the classification in general that can be used between data sources. So like that. The data lake implementation in BPS, we use technology like Hadoop. And for data warehouse, we use RDBMS, such as DB2 and SQL Server. And for now, we already in the migration step, because there are so many data and many format, and to go to data warehouse, it's a long journey actually. Thank you.
Yeah, thank you, Ibu Isnaini and Pak Hanif. Uh, yeah, it will be interested also. For example, you mentioned Hadoop. Why BPS choose Hadoop? Is it the ideal one, or is it the easy one, or this is the optimal one because of the resources and the knowledge, for example, like that? Could you elaborate with this? Why Hadoop, for example, and not others?
For the first time, we choose Hadoop because there are the consideration about how to manage data in BPS. They have not only structured format, but also unstructured format. And Hadoop can store that not only structured, but also unstructured. So we want to make a single source of truth, one data in BPS. So if we store the data in Hadoop, they are engine processing that can be utilized by data scientists or data engineer to process the data. So the data will be ready for to move to a data warehouse. And we consider about preparation of a data warehouse scheme, because if we wait to final scheme for data warehouse, it will be it will need a long time, and we choose to run partial. So we have a data lake and we have a data warehouse. So if we already have a data that is ready for predefined scheme to move to predefined scheme in data warehouse, we will load the data to data warehouse. So in data lake, it is the last consideration is about big data utilization, because in this era we try to utilize the big data, and the size of the data it's very huge if we compare with our survey or census data. So it is they are a consideration of us.
Yeah, thank you. Maybe any participant would asking or share their experience. It would be good if we could share each other.
Today material is most of a concept, because we think we have to know the concept first, and the hands-on we will give in the second part of a sharing session.
Okay, thank you. Yeah. Rian?
Yeah.
Yes.
Okay. So thank you very much for BPS. We appreciate your effort on preparing this workshop. And also thank you the IMS who already participate in this workshop. I also want to remind again that there will be the second and third part of this workshop, because this is the workshop series. It's scheduled to be conducted within this year, as mentioned in the invitation. And for more update, we will send you any update by email. And after this, we also send you Google form for the questionnaire to read this workshop and for our further improvement. So maybe I think BPS also agree if the IMS have the question related to this workshop, they can send the email to the BPS.
Yes, of course. Excuse me, Rian. There is one material about data pipeline. This is the last material for today.
Oh, sorry. I'm sorry. I thought
Will be delivered by Bu Ita.
Okay. I'm so sorry. Okay, so Bu Ita, the floor is for you. You can start the presentation. Thank you.
Okay, so we can start directly without a break. Shall I just continue?
Yes, please. Thank you.
Okay, wait. Excuse me for a minute. Can you see the slide now? Hello?
Yes, you can see the slide
Yes,
clearly.
see. Yeah.
Thank you.
I'll try to start the presentation.
Okay.
Okay, thank you for the opportunity and good morning, everyone. Continuing from where my colleagues have left off, I'm going to try to explain about data pipeline. Okay, so now that we have learned about what is data engineering in general and what is data modeling and what types of storage are there to store the data, I'm sorry. Now I'm going to try to explain the pipeline. That's the set of process itself to manage the data and to ensure that it flows smoothly from the source to its destination. Okay. So the first slide is about data pipeline in general. Before I move to explain the slide in detail, I would like to explain about the pipeline itself. So what is a pipeline? A pipeline is basically like a channel where a service or a product flow from sources to its destination, which usually is the end customers. For the analogy, you can see like in oil or water pipeline, it's basically a set of pipes that deliver water and oil to its destination. And then for data pipeline, the product is data. So data pipeline is vital to ensure that the data from the sources can be delivered in a smoothly and seamless manner to the end customers. That's user or maybe data scientists or maybe business intelligence analysis and some other roles that's related to the data. It depends on the organization, but basically that's the meaning of data pipeline. And it's also been said somewhere that good pipelines can be the lifeblood of the organization. And this sentences, I believe, is like, it emphasizes the importance of data pipeline itself, because if the data pipeline is not mature, if it's not clear, if it's not managed well, then the whole process of providing data can be like disturbed, and then can be like, what do you say? Can be like slowed down, and in the end we can like provide the data in a timely manner, in a way that we want to, in a cost-effective manner, and yeah, and we can meet the customer needs. And yeah, so maybe you've seen this slide before. This is the slide that has been explained in the first session by Bu Novi. It's an example of data engineering. So from this slide, I want to explain about data pipeline in general. But before that, I want you to know that the term for each phases in this process can differ, depends on the reference that you find, or maybe your environment, or maybe your usual work. It depends on that. But for general, this is the term that's mainly used, and mostly there are like 4 phases for this. The first one is collect. So from the example, data crawling from marketplace website, this is the collect phase. This is where you collect data from the sources. And then after that, you move the data through an Etl process. And then you come into the prepare phase. That is, in this example, is data flow monitoring and data staging. So from the collect phase, you move the data into a data staging, and then you monitor the process. And in that data staging area, you can start to like prepare the data for further processing, for further analysis, and some stuff like that. And later we can discuss in detail about what this data preparation consists of, or what kind of process it contains. And then finally, after the data is done being prepared, it's done being cleansed and transformed, you can perform an ETL again, or ELT, it depends. And then you use that for analyze phase. In the analyze phase, you can perform data processing, data analysis, and usually you done this in like data warehouse. But then again, this is just like a common practice. It can differ according to your needs or your use case. And maybe we can share about it later. And then finally, after you've done with the analysis, you can perform another ETL and provide the data for the analysis and visualization. so your end user can consume the data in a manner that's easy for them to understand and use. Okay, and for these 4 phases, where is which part that the engineers takes heavily part in? So in these 4 phases, basically data engineers only heavily take part and contribute in collect and prepare, because that's where technical issues related to data mostly happen and where it needs engineering technique to solve them. This term data engineering comes from, because in the analyze and visualize phase, usually there is not much technical issue regarding, I mean, there is still issue, but not as much as in the collect and prepare phase. Thus, the engineering is not as much needed in these phases, but rather in these phases, the data engineer needs to collaborate with data scientists and it's business intelligence analysis, maybe in visualize phase, and then they can find a way to like how to manage the data, how to process the data in a manner that can satisfy the user's needs. And okay, that's the data pipeline in general. And then next. Okay, so among all of the 4 processes, we can see that there are a lot of like ETL or Elt process. So what is that process exactly? So ETL or Elt process is basically a data loading process. So it is a process where you load a data from a storage to another storage for different purposes, for different needs. And like for this example, for the previous example, you move it from collect from the sources to data staging, so you can prepare it, and then you move it from data staging to data warehouse, so you can process and analyze it. That's the example. And now we're going to talk about the ETL or Elt process itself in a bit detail. Oh, sorry. Okay, so basically this is like the general process of ETL or Elt itself. As you can see here, it starts from a data storage and end in another data storage. So from that, the main component part of ETL is basically extract, transform, and load. But then again, there is also another process that's called Elt, and that stands for extract, load, and transform. So basically, the transform and load part can be performed interchangeably. It depends on your needs or your organization needs. Like for example, that's been given by Bunovi in the first season, in the first session. When you load data into data lake, usually the process that you do is Elt, not ETL, because data lake can store data in various type, in various format, so you can just store your data as it is without performing any transformation or whatsoever. So you can just load it first, and then later you can transform it. Depends on the needs of the data, of data scientists, of the end customer, like that. Okay, so for the extract process, what is the extract process? The extract process is where you extract this data from data sources. So from the previous example is where you extract sales data or maybe product data from marketplaces. Like usually the data is displayed in a web, and then you try to like extract this data in a form that you can later process. And usually you perform like a set of select queries, but yeah, maybe not a simple select queries. Maybe you select blah, 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 where blah, 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 something like that. It depends on the needs, but basically, yeah, you select the data and then extract the variables that you need in the form that you need. That's the extract process. And then the transform process is basically where you do some kind of data type conversion or data join or data lookup, and then also general data transformation in general. We will discuss about it later because we're going to talk about it also in data preparation. But for now, the transform is basically the process where you change the data, where you transform it into another form. And then load is where you finally save or place the data that you've already extracted and transformed into the final or destination storage. And then usually, if for the extract phases, you do like select queries. For the load phases, usually the queries that you perform is insert or update queries. insert for the new records or update if there's like a change in the value for that records, for a certain records that's already in the data. Which query you perform, it depends on your needs. Yeah, so talking about like data pipeline, it's actually like a really use case basis. Yeah, I can talk about it in general, but in like when you perform it, when you've done it yourself, it really depends on your use case and needs. So yeah, we can talk about it later. We can share about it and discuss in detail later. And then the challenges that is faced throughout the whole process of ETL or ALT is, I basically like summarize it into 6 points. That is a scheduling. So as you know, the data loading process can be performed as a routine operation or can be performed as an ad hoc operation when you find like new data sources or when there's a new request. But for the request that is on routine, that's already scheduled, that's already major, usually you try to schedule that. So like maybe daily you perform like data extraction daily, you perform like data loading daily, weekly, or monthly, it depends on the data. And then the data type is basically about the various format of the data, how to ensure that the different formats of data type doesn't like disrupt the whole flow of the pipeline. Because as you know, different technologies sometimes support different data types. So you also need to consider that into account when you design a data pipeline. And then another challenges is data consistency and data integrity. These 2 points may be a bit similar, but basically data consistency is more like about the completeness of the data. So how to ensure the data that you've loaded or you've transformed, you performed ETL from the source is the same data that you accept, that you receive in the final storage. And usually to ensure this, you can perform like checksum or row count, something like that. And then for data integrity, it's more like about the correctness of the data that's being accessed by user. So for the example, the data is in float format. So you got to ensure that it doesn't show as a string or as an integer where it lost its accuracy. That's the thing that you need to consider. And then for performance, this is related to the like main challenge of big data itself. Like the data is so huge and enormous, and sometimes also the technology is keep on changing, keep on evolving to like accommodate that huge amount of data. Sometimes the adoption of technology itself can ensure performance. You need to like perform configuration and reconfiguration, and it's like a continuous process that's need to be improved, depends on the needs and the volume of data. And then the pipeline maintenance. This is due to the fact that as the technology evolves, as the industry evolves, the needs also evolves. So sometimes maybe the data scientist needs this kind of data, but then another week or another month, they found a new data source. So you need to like maintain your pipeline, you need to adjust it so it can like collect data from that new data sources, something like that. You need to maintain it in order so that it can keep providing the needs of the scientist and its end user. And then these are several tools that's commonly used for ETL or ALT. Of course, this is not the only one, but this is like some that's most used and most known out there. For more tools, you can search in a Magic Corner quadrant. But this is the example, like Talent. I think there's also like a free version of this. And then there's IBM DataStage. There's also Pentahome, SQL Server, SSIS. SSIS stands for SQL Server Integration Service. So it's a service and product from SQL Server that focuses on data integration, including data ETL. And then there's also Scoop. Maybe this is a bit hard to read, but yeah, it says Scoop. Scoop is a service that's part of Hadoop. And then you can also use it for ETL or ALT from moving data from other sources to data lake or from data lake to other sources. vice versa, it can also help that. Okay, that's for data loading. And then next. Actually, this is a new slide that I just add because I think that maybe I need to explain this for you to gain like a better understanding or a better view of the ETL process. Maybe I will try to update the slide later in the drive so you can download it. So this is like an example of ETL or Elt process, and the menu are like features that you can find in ETL or Elt tools. So the example that I take here is from SQL Server SSIS, because if things are go according to the plan, that's one of the tools that we're going to use in the part 2 or part 3. So you can see from this menu here, from the toolbox, there are like various features that you can use. Some of that are like this one. Yeah, you see there's like data profiling tags, which can help for data cleansing. And then there's like expression tags, which can help for data transformation, data calculations, aggregation, some things like that. And then there's also like a send mail tags. So this will be helpful for your monitoring process, because you know one of the challenge in ALT is scheduling. So to ensure that your ETL job is run as scheduled, you need to monitor that. So this send mail tags can be helpful to like notify you when there is something wrong in your ETL process, so you can get notified right away through an email. And then there is also like destination assistant and source assistant. So basically, as it has been explained before, the main purpose of ETL process is to transform data from sources to destination. So source assistant and destination assistant will help you to connect to the data source or destination data storage that you want. For the example, there is like, this is other destinations. And then below that, you can see like raw file destination, SQL server destination, flat file destination, or OLEDB destination. So yeah, for this example, in SSIS, you can connect to like various type of data storage, from flat file, databases like SQL, or actually there's also like a connection to source like data lake or Hadoop, but it's not shown here. Yeah, so basically that's the main menu in ETL or Elt process. And then this is an Elt example. Wait, okay, I'll try to zoom in. Basically, this is like for a customer. So for the example, your source is a OLEDB source, that is a database sources. And then, okay. And then you can perform like conditional split. This is, for example, when you want to like separate the data, the record that is new, you can perform like insert query, or you can perform update or delete query for record that needs to be updated, or for records that's no longer relevant. For example, insert is when you find a new record of new customers, and update is where one of your customers updated their data, and delete is maybe when your customer is no longer active, something like that. So for the data that needs to be deleted or updated, you can remove the record, and then you can store it in a table. You can call it is updated, for example, and then you can perform a union between the new data that has been inserted and the data that has been updated. You can perform a union, and then after the data is being joined, you can perform like a customer lookup. So for this example, lookup is like when you want to, let's say this is a sales table. So in the sales table, maybe there's just like name, attribute name for the customer. And then you want to like know where are the customer coming from what age range are they. Mostly you want to do like customer segmentation. You can do a customer lookup and join the sales tables with the customer tables to gain a better understanding of your customers. And then you can see which which record that's match, which one is not. And then you can also like perform a lookup with the product table to ensure that you can get better information regarding the product that they buy, what is the characteristic. So yeah, maybe you can perform like analysis in order to increase your sale in the future. And then finally, after you've done all of that, you can save the data to another, it can be another database or it can be the same database. It depends on your need. So yeah, as we have explained and we have learned before, basically this one is Etl process because we do a transform. This is the extract phase, this is the transform phase, and this is the load phase. Okay. Next, we're going to move to an explanation about each phases in data pipeline. So the first phases is collect phase or data ingestion. It is where you collect data from various sources. And as it has been explained by Bu Novi in the first session, the main issue of data engineers is like there is various technologies, various data, and then also various data source, various data format. That's the main issues of data engineers. So for this example, the source, I'm sorry. For this example, the sources for data ingestion can be like from censuses and surveys, because we are National Statistic Office, or from administrative data, and finally for big data. So why is census and surveys not considered as big data? Because as you know from the first day, from the explanation in the first day, we know that the characteristic of big data is basically volume, velocity, and variety. Like that's the main characteristic. So maybe for census, it can make the characteristic from the volume side because it also like produces a high and huge amount of data. But from the velocity and the like variety side, maybe it doesn't meet the criteria of big data because the data format is not that much in varieties compared to big data, or maybe like the velocity, because census in Indonesia case it's like it performed in 10 years. So yeah, it's not as, the velocity is not as high as big data that comes from, for this example, marketplaces, sensors in your phone, GPS, something like that, or for Google Trends. So yeah, for big data pipeline, the source that we mainly use is usually like this Internet of Things, like marketplace, sensors, or maybe like device, gadget, something, you know, there is currently smartwatch, something like that can also be a source of big data. And then yeah, your phone, your mobility can be tracked from that. And then Google Analytics can also track various amount of data. And then after we understand the variety of the data sources out there, we also need to understand that there are also various type of data, various data format. As you can see, there's like an Excel, CSV, PDF, TXT, like starting from the, what do you say? Maybe like the one that's flat file, and then the one that's database, SQL, or maybe also in an XML, JSON, or even PNG format, which is like a picture, because one of the main characteristics of data is variety, right? So the variety of the format is what makes big data both useful but also challenging. And then after you consume those data from a certain sources and you like collect data in a format or type depending on the sources, you perform the data loading, or basically the Etl process. So the process can contain like bulk ingestion. This is when you like perform a migration of big data, or you can perform export, import. This is usually when your source is like flat file. Usually in tools like SQL Server, there are features for like export or import from flat file. And then there is also like streaming process. This is usually used when you collect like real-time data, like where you stream from marketplace, from like sensors, from IoT, something like that. And then the process that's also really important is the monitoring phase. This is where you monitor your scheduling. This is where you monitor whether or not your data has reached its destination, whether or not the size of the data or the amount of the records is the same in the source and in the destination, something like that. And then the main issue in data ingestion and data collection is basically data accessibility, resource availability, and dynamic needs. For dynamic needs, this is basically an issue for every phases in data engineering, because as you've seen in the first session, one of the challenges for data engineers is like the data pipeline maintenance, and then like the requirements that keep on changing. So yeah, dynamic needs is like a main issue in every phases. So maybe we'll mostly talk about data accessibility. So what is data accessibility issue? So this issue arises when you use big data, because big data is like, you can say that it is a free source. It's a source that you collect from the internet, where you collect from the mostly internet, let's say. And then usually you don't have to like spend a lot of money for that, because that's like one of the advantages about big data, right? They say that it's cost effective. They say that it's more cost efficient compared to census and surveys. But then, as a trade-off for that cost efficiency, there's an issue of data accessibility or availability. So because the data is belong to the third party, and yeah, sometimes they also need like uh, let's say make profit. Sometimes they also like offer for consumers or for data users to buy their data. So of course, there's going to be a difference between those who buy the data and those who like consume the data freely. So maybe like those who consume freely can only like access for certain size of data in a day, but those who paid can like access more data in a day, something like that. And then there's also another issue is that because it is like a free data, because there's like no agreement or MOU whatsoever, it is very possible that they can change the structure in their data the sources, in their API, and you need to adjust your pipeline. And sometimes even when you have adjusted your pipeline, the third party, the owner of the data source, sometimes they also improve their technology. So your pipeline no longer works anymore, your coding no longer works anymore, like they increase the security. So yeah, the data is not accessible anymore. So you need to find another data sources. Like that's one of the main issue in big data collection. And then for resource availability is mostly regarding to the data storage, because in big data, one of the characteristic is volume, which signify the amount of an enormous data that we are collecting. So we need to ensure that we have an available resource that can handle and manage that. And like that's one of the reasons why we use Hadoop. And then the tools that you can use for collection is, there is several that I've mentioned. You can use like for commercial off-the-shelf tools like Codes tools. There's IBM DataStage, or maybe for I believe that Pintaho can also be used for this for collection. And then another is like the open source tools. You can use Storm. Storm is a service that's a part of Hadoop, or you can use Python for web scraping, or yeah, for web crawling. And then you can use Selenium. This is like similar. I mean, this is like the also an open source, but it offer a like user interface. So instead of you need to code, where in Python you need to code, in Selenium you can use just like drag and drop, depends on your needs. But yeah, maybe it has some limitation compared to where you code. And then finally, after you define your data source, you understand the format, you perform the data loading, the data can finally be saved into a data storage. So this is a various type of data storage. Which one that you use is depends on your needs, depends on the data that you collect, depends on the availability in your organizations. And then the characteristic of each of them has been explained by my colleague Mas Hanif before. So for example, maybe you can like collect big data, and if the format is like structured enough, you can save it in database like SQL Server or Oracle. But if you collect data that's in a structured format like PNG or maybe like JSON, something like that, or maybe like even in still in TXT or PDF, then for easier, let's say for easier saving, you can just load it into Hadoop first, or maybe AWS or Google Cloud if you want a cloud-based technology that depends on your needs and availability of technology. Okay, that's for data collection. Now moving on to data preparation. So data preparation is where you continue from data storage and moving on to another data storage. So basically, actually this is depends, but once again, maybe I'm going to like repeat this sentence often today. Yeah, but basically it depends on your needs. For some cases, organizations like implement two different data storage, that is the staging storage and then the target storage. Why do they provide two kind of data storage? One of the reason is because sometimes for staging storage for collect phase, you need a data storage that is write intensive. So there is no issue when because like when you save data, you need to write, you need to perform insert and update query, which is basically you write the data into the data storage. So for that, you need a data storage that is write intensive. But for target, because after data preparation, the phase is data analyzed and processing, and the what do you call it? And the query that you use is mostly select or something like that. So you need a storage that is read intensive. So that's one of the reasons why some organizations might divert their data storage. And then for the process, it's basically similar. From this data storage, you move that to another data storage, but maybe the difference is in the detail of the process, the issues, and the tools. So for the process in data preparation, so yeah, like I've said before, data collection and data preparation is where most of the technical issues happen, where most of the engineering takes places. So yeah, this is because like you collect data from the source, and sometimes the data is like not in the way that you expect it to be. Like sometimes there's noises, sometimes there's like unnecessary value, and yeah, and sometimes there's just a lot of stuff that you don't expect to be there, but it is there. So you need to do like engineering process to cleanse the data, to like refine this data so it can finally be used in a data scientist for analysis. So some of those processes like data conversion, and then there's also data cleansing, usually using machine learning. And this is related to the one that has been explained by Bunovi, where the skill of data engineers and data scientists sometimes overlap in machine learning. It is because for data cleansing, especially when the amount of the data that you need to cleanse is so huge, you need to use a machine learning method for that. Like you can just use like a basic SQL query anymore sometimes. You need to like perform what do you say, classification, clustering, but for cleansing. For cleansing means, I mean, not for analysis. Yeah, you need machine learning for that to like matching data, and yeah, for data integration, sometimes you also need machine learning. And then there's also data transformation where you transform the data. And the tools that you use is, yeah, it has also been mentioned before, Python. We have learned a bit about this before in the previous day where we have introduction to Python. And then there's also a Scala and Spark. So Spark and Scala, it is related because Spark is serviced in Hadoop, and usually it uses Scala programming language, but nowadays it has also like been integrated with Python or R. So there's also like PySpark, AirSpark, something like that. And then there's also Hive. So Hive is like basically an SQL-like, but is in Hadoop. So supposedly it can handle like a larger data compared to the usual SQL or usual databases. And then that's for the open sources tools. And then for the commercial of the self tools, there is Pentaho, DataStage, SQL Server SSIS, or even Kovacs Kapau. Now, what is the main issue in data preparation? So as I've said before, data preparation is where the technical problems takes places, right? So what are those technical problems? Some of those technical problems are data completeness. So sometimes when you perform an ETL, when you move data from its sources to its destinations, things just happen, and then some data are lost along the way. The data is not complete anymore. So for example, like in the source data, you've got like say 1,500,000 records, something like that. And then in destination, you only get like 1,200,000. Yeah, so there's like some of the data is not transported correctly. There is like a gap in the row count, something like that. And then the second issue is data accuracy. This is regarding to the data format, as I've mentioned earlier, like data integrity and yeah, similar like that. And then for data usability, this is regarding to the condition of the data. Yeah, because like similar to, let's say to water or to oil, when you take it from the sources, it's mostly in a dirty condition, right? Like you need to cleanse it first before you can use it. So, and sometimes even after you cleanse them, like the condition is that bad, it is that dirty that you can no longer use it, no matter how much cleansing you've done. So yeah, that's also an issue of data usability. And to ensure like the effort that you done to cleanse that is worth it in the end. So yeah, you also need to like perform identification or assessment of whether or not this data is usable, whether or not it is still can be cleansed, whether or not it can be transferred or refined for further use, something like that. And yeah, maybe you can do that in your first try or whatever. It's like experience and maybe like some trial and error before you can finally find the pattern of which kind of data that's not usable, no matter how much you try to cleanse it. And then there is also an issue of performance because the process, this kind of process, conversion, cleansing, integration, and transformation, this can be a complex processes. I also I say that it's maybe just it is a select, insert, update query, but inside of that, it's like a combination of a complex code and complex scripts, and combine that with the amount of data that's being processed, it really puts a huge burden in the computing engine, I mean. So you need to ensure that the performance of your platform, of your technology is reliable enough and it can handle that process. And then the dynamic requirements is also an issue in here because maybe like sometimes the data science need this variable, but then another time they found that another variable is most suitable for their analysis. So you need to change your code, your cleansing method or transformation method, something like that. And that's for data preparation. Oh, wait. Yeah, actually, I add another slide again. Because I want to like explain data preparation processes in a bit more detail because this is where data engineers heavily contribute in. So I just want to make sure that, yeah, it's understandable in a more clearer manner. So this is the process in data preparation. Basically, there are like various terms for that, various process for that, but I'm just going to summarize and include what I assume is the 4 main processes. So the first one is data cleansing. Data cleansing is where you cleanse data from unnecessary noises, where you ensure that the data is in a clean condition and in a refined condition and can finally be used. So some of these some of the steps that you perform in data cleansing mostly include like missing data handling, and whether or not you want to leave the data as it is, or you need to impute the value for that missing data, or maybe you want to like perform maybe you want to perform imputation, like whether it is a basic imputation using the group average or median, or maybe like the more advanced imputation using like machine learning, KNN algorithm, or something like that. And then you can also, and then usually for data cleansing, you also deals with like noises data. Okay, so for missing data, sometimes when the missing value is only in certain column, you can perform imputation. But if the missing value is in several columns, then sometimes it's hard to do imputation because you have no basis, let's say, for like to do the imputation itself. So sometimes you just need to clean those data and exclude it for further analysis. And then for data conversion is when you convert data from one type to another. For the example is when the data that you collect is like in TXT format. So it's in a long text like that, when you write in Word, in Microsoft Word in a notepad, but you want to process it. So you need to like convert those data into a type that's more processable, let's say. So for example, you can convert the TXT format into a CSV format. And then the challenge for this is how to define the right delimiter, the right separator, and then the right escape character, and stuff like that. Because sometimes if you use the wrong or the incorrect data delimiter or escape character, the data can be misplaced. Like for example, there's like a name column and address column. If you use incorrect delimiter, like the data that supposedly should be in address column can like moved and misplaced in another column, like in a name column when you read it. So you need to take account and put that into consideration when you perform that data conversion. And then there is a data transformation format. This is where like most of the data preparation usually take place, and this one is the process which usually takes a lot of time, but then again that depends on the need. So what are data transformation actually? So data transformation includes various processes such as like creating new variables from other variables. And for this creation of new variables, usually you perform a series of calculations. Like for example, in customer, let's say for our marketplace data, you want to calculate offset. So like the net profit of each stores, but the variable is not available in the data. So you need to like perform calculations by multiplying the price data and the sales data. So how much product is sales and how much is the price of the product, you multiply that, and finally you can get the net profit for that product. That's one of the example of data transformation, but that's the simplest one. Like, and then there is also like the more complicated one, the more complex one, like where you need to multiply first, and then you need to divide it, and then like you need to compare it with another data to ensure that it is not an outlier, something like that. There's also like a complex process like that. It depends on the needs for the data itself. And then you can also like another common process in data transformation is like performing grouping. So for example, the original data, there's like a sales, right? A sales number. So this product is, the sales for this product is something like that, like 100. And then there's also a product that the sales is only like below 10. You can also like group the stores or groups the shops based on the sale that they make in a certain product or something. This can be useful for analysis later when you perform analysis based on classification or clustering this can be useful for that. And then lastly, there is also data integration. This is where you usually integrate or join your data set with another data set. So for the example for marketplace data, you can like integrate the product tables with the customer tables and then with the sales table to gain like a comprehensive table that comprehensive data or information, I mean, that encompass all of that information from product sales to customers. Or also, since we are a National Statistic Office, we usually also like performed data integration with our master or reference data set. So for the example, for the marketplace, usually there's like a data, right? So this shops is located in which area, or the sales is made from which area. This record about area, later on we can join this with our master of administrative area frame. So maybe later on we can like perform a comparison or benchmarking between the sales data that we obtain from big data and the sales data that we obtain from official surveys, something like that. Like that's one of the benefit of data integration. Okay, but that's the processes of data preparation. But just so you know, each of the process can be like can be performed interchangeably. So you can do data conversion first, then data cleansing, or data integration first, then data transformation. It really depends on your use case. Okay, and then next, now we're going to talk about analyze phase or data analysis. So for this phase, maybe there is not much of data engineer contribution, but still, because in analyze, you still need to like perform an ETL and data loading from the data storage, which we called target previously, the one that needs to be read intensive. Sometimes for this too, sometimes organizations provide two kind of data storage, different kind of data storage, or maybe like the same data storage, but with different databases, something like that. So the first one is storage for data that has been cleaned through data preparation phase. And the destination is data storage for data that has been further processed and further analyzed, and later on to be used for visualization. Okay, so the process in analysis is basically and mostly consists of machine learning, statistical modeling, multivariate analysis, artificial intelligence. So this is, yeah, you can say like this is like really the playground of data scientists. This is where they play with modeling. This is where they play with various complex algorithms to obtain the best model, so they can like predict data or like make an inference about data. Yeah, this is basically why data scientists usually need a more advanced machine learning skills for analysis. And then the main issue for this is like data quality, performance, and resource availability. So resource and availability and performance issue is actually similar to the one that I has explained in the prepare phase. So basically, since this is like a whole amount of data that you're processing, that you're analyzing, and the process is not a simple process, it's mostly a complex process where you perform a series of modeling, like you use a trained data set, you perform a various kind of simulation before you can finally find the right model, and then you apply it to your like trained data set or test data set. So yeah, performance is like an important factor for that, for the analysis, because if the technology is not reliable, the performance can like take a really long time. And we don't want that because we want to deliver data in a timely manner. So that's a point that's also needs to be taken into consideration. And this is related to resource availability, because resource availability will definitely affect the performance. And now for the main issue, data quality. So as I've said before, the technical issues regarding data mostly happen in like data preparation and data collection. But in data analysis, there is also a leftover, let's say a leftover problem regarding data issues, because as I've said, even if you have like cleanse the data, transform the data, sometimes some data just the condition and the quality is just that bad. So like the data analyst, the data scientist needs to find a way how to overcome that not so good data quality, whether or not they use a model that can overcome that, because you know sometimes different model can only work for certain kind of data. Like this model only works for data with normal distribution. This model only works when the machine value are low, something like that. So it's a challenge for data scientists to find the right model, the right machine learning algorithm to overcome the data quality issue. Because if after some kind of cleansing and processing and transformation, it's still the quality is still not good, then there is nothing left that the engineer can do. So yeah, the task is then handed to the data scientist. And then for the tools that can be used for data scientists, there is like open source tools like Python, Spark. Yeah, Python and Spark, this is like similar to the one that we use in data preparation or data refining phase, because yeah, with these tools you can perform like not only machine learning, but you can also perform various statistical modeling depending on the package that you use. So you can use that, Python, Spark, R, or maybe the combination, PySpark or Spark R. And then usually like for the interface, you can use notebook. As we know in the previous day, for Python, we use Google Colabs. I don't include that here, but yeah, just so you know that that's one of the interface that you can use. Another one is Jupyter Notebook. You can run Python in here. And then there's also RStudio for R. And for Apache, this one is Apache Zeppelin. This is usually this come with Hadoop. This is one of the service that's provided in Hadoop. You can also write code in Python, Spark, or R language in here. So yeah, you can use that as an interface for scripting or coding if you are a data scientist. And then for the commercial of the self tools, like usually this tools is the one that's more user friendly, and then the ones that's, because they are commercial, usually they have more support from the product owner. Maybe ones that's mostly known is SAS, and then there's also IBM Cloud Private for data, and then there's also RapidMiner. Usually you use RapidMiner when you perform like mining, text mining, and then classification, and yeah, something like that. And finally, after you've accessed the data from each initial data storage, you perform the analysis as you need, you finally save it and load the data into the data storage, or we call it the final data storage. So the data engineers in this part mostly takes part in the ETL phases. So how to provide the data storage that can be accessed by data scientists through various tools that they use, and how to save the data that's produced by the various tools that they used into the data storage final. That's where data engineers take place. And then finally, the visualization, or yeah, the visualization phase. So as I've said before, some organizations sometimes use a different data storage for visualization, right? This is because for visualization, most of the time you need the one that's also similar to analysis, the one that's rate intensive, and sometimes you also need to use the one that support OLAP or data cube, something like that, because you want to create dashboard, right? And yeah, so this is where I like replace some of the previous database, and yeah, there's IBM DB2, for example, for data warehouse, or you can use Oracle, SQL Server, something like that. And yeah, the process for the visualization itself is basically creating data cube or data mart, and then creating charts or graphs based on the data, and then designing the dashboard. So dashboard is basically the collection of the charts and graphs, right? So after you create each one of the chart, each one of the graphs, after you modify them, you try to collect them, to compile them and integrate them in a dashboard that's like visually pleasing, but also informative for the end user or for stakeholders. So you can, so they can gain information, easier access to information from that without having to like directly access the raw data, something like that. And then the main issue in data visualization is usually in regards to data format, readability, and data access. Of course, performance and resource availability and dynamic requirement is also an issue. But for now, we're going to talk about these three. So data format is about how to ensure that the data is provided and displayed in a format that's also readable and also understandable. It's related to the second point. So for example, if the data is like in decimal, like how much digit should be displayed in order for the user to still like gain the accuracy of the data, but still make it easy to understand, like not complicated for them. Because if you like include too much digit, like 7 digit behind comma or something, then it can be overwhelming for them, right, to understand the data itself. And then for readability, it's related to data format, but it's also in relation to the how the chart and how the graph is arranged in the dashboard. Because if you've like incorrectly arranged the data, or like you place irrelevant chart, maybe the chart that's not so related next to each other, then it can make it confusing for the let's say end user or stakeholders to get information from them. And then the last is data access. So yeah, for data format and readability, this is basically an issue that needs to be solved, that needs to be overcome by data scientists or business intelligence analysis. It depends on the role on your organizations. But for data access, this is the issues that needs, data format too, actually. This is issue that also needs to be faced by data engineers. Because then again, also data engineers don't take part in like creating charts, graphs, or designing dashboard. They can help taking parts in creating data cube, creating data marts, and to ensure that those data cube and data marts can be accessed in a easy yet secure and effective manner by the visualization tools. So that's the problem. And then regarding data access is more like, because sometimes not all of the data are provided for the same people. Like sometimes a set of data is only provided for a certain kind of people, and then another set of data is only for a certain group of people. So how to like limit and manage the authorization to the data is also a problem that needs to be solved by data engineers. The tools that we can use for that is there is open source tools like, then again, this is also similar, Python, R with the user interface using Jupyter or Zeppelin. This is also a tool that you can use for data visualization, because in Python there's like matplotlib package, and in the R there's like ggplot package where you can like create various visualization, various charts and graphs from the data that you have analyzed or you have processed. And then for the commercial of the self tools, there is like Power BI. I think this is one that's most widely known besides Tableau. So Power BI and Tableau is, I think, one of the tools that's most widely known. But there's also like AutoSolve, a Cofax Insight, and there's also like IBM Cognos. Yeah, there's various tools, commercial of the self tools. And sometimes they also offer like free products, but yeah, there's usually limitation, like maybe you can't publish your dashboard or something like that. And then this is SQL Server Analysis Service. Maybe this one is not exactly an ETL tools, but I'm sorry, it's not a visualization tools, but this is also a tool that helps in visualization phase. Because in creating data cube, when creating data cube, you can do that using SQL Server Analysis Service. So you can load your data into SQL Server, and then with SQL Server Analysis Service, you can create data cube, you can create measures, and then you can define the dimensions that's needed for the data. And finally, your visualization tools can access that data cube that you have made in SQL Server Analysis Service, or in short, SSAS, SSES. Yeah, so if you've created the data cube and SQL Server Analysis Service, so the burden of processing is no longer in your visualization tools. And by that, we hope that the visualization tools can run more smoothly and more effectively. Okay, and then the end result is dashboard or visualization that you displayed for your customer, for your end users, or for us, maybe stakeholders, or maybe the citizens in our website, maybe. And then the role of data engineers, like I've said, is mainly in dealing with issue like data format, data access, and creating data cube, which we can do with one of the tools is SQL Server Analysis Service. Maybe if we have the opportunity and we have the time, we will try to explore more about this in the part 3. Okay, that's all of the phase in data pipeline. And lastly, I would like to let's say summarize the data pipeline main challenge. So basically, this is similar to data engineering main challenges, but maybe some of them are more detailed. Depends in regards to what I've explained. So for like data, the main issue is that its format is really various. There's really a lot variety of data out there, and it is so enormous and endless. So the one of the one of the solution for that is to ensure the data standard and to perform data retention. So data standard can help you deal with various format issue. Like basically, if like you only use a certain set of standard, then your effort can be focused on like exploring solution for ETL process regarding that standard instead of trying to facilitate all of that format. And then for data retention, this is regarding the huge and enormous amount of data that we keep on receiving in endless manner. We can perform data retention to ensure the sustainability of our resources, because yeah, we just can't keep on like buying new server, buying new database, something like that. We also need to like implement a data retention to help manage this data. So maybe the data that's not actively in use can be like stored in different data storage, or can be archived, something like that, to like conserve the space in the data storage for the active data only. And then for the technologies, the issue is the various technologies, but various technologies combined with the available expertise. So technologies keep on evolving. There is always like new technologies every day, but sometimes the expertise, the development of the expertise or the improvement of the expertise that we have is not evolving as much as that. So some of the answer for that issue is to utilize existing technologies. So because yeah, we don't always have to like obtain the latest technologies. We don't always have to like own whatever is new out there, whatever is just released on the market, because we need to ensure and make sure whether or not it is in related to our organization needs, and whether or not the current software or technology that we need can like manage or handle that needs. Like we really need to question ourselves, especially since we're like a government institute. Yeah, we need to really consider like, do we really need to buy new technology for this? do we have the right expertise to manage that? Is it really necessary? Something like that. Is the cost worth it? Like that's several questions that we need to ask ourselves. And then another one is, in case you really need to adopt new technologies, in case the technology is really obsolete and can't be used anymore, and you need to adopt new ones, you need to ensure that you have resources that have the right expertise to handle that, or maybe if you haven't have that yet, you need to design a like capacity building plan or roadmap for them. So when you adopt the technologies, they are already like know how to learn and how to utilize them. Another one that you need to consider is the maturity and stability of that technology that you want to adopt. And then for performance, I've talked about this quite often. Basically, it is about the rapidly growing demands with the in this industry 4.0, that where data keeps on coming, technology keeps on evolving, the demands also rapidly grows, but then the resource availability sometimes also didn't grow as fast as that, as much as that. So one of the solution is continuous tuning and configuration, like reconfigure. You need to keep on performing that, like you need to maintain that performance. Yeah, so you need to like perform regular tuning and configuration to ensure that. Because sometimes like the technology is actually capable of handling that, but because we haven't configured it correctly, then it seems like the technology can't support that, when the problem is actually in configuration, not in the technology itself. And then the others issue in general is about the dynamic requirements that keep on changing and the pipeline maintenance. So as the requirements keep on changing, keep on improving, you also need to keep on maintaining those pipelines. So yeah, basically the solution is also continuous improvement. You need to keep on improving also. This is why one of the challenges for data engineers is that they need to learn on their feet, because like there is no time for you to study and then try to apply that knowledge that you've learned in the use case. Because sometimes when you just finish studying one use case, there's like another new use case coming in. So yeah, you need to learn fast. Like that's one of the biggest challenges in that. And then another, as the issue is in governance, like lack of governance in unclear strategy. So the solution for that is to ensure a clear governance and a clear strategy for data pipeline. That's including its supporting technology and its roles and responsibility of the data engineers and data scientists. So yeah, hopefully with this governance, with its continuous improvement, with this continuous configuration, and yeah, all of these standards that we apply, we can like overcome bit by bit the issues that we faced. Okay, so I think that's all from me about data pipeline. Maybe if we have time, we can like have a short discussion, or I don't know, is there any time for quizzes?
Yes, I think we still have time for 1 or 2 questions, please, for the from the participant.
Anyone?
Any question?
Or maybe other National Statistic Office representative can share their current data pipeline, the tools that they use, because you know in part 2 and part 3 we're going to perform a hands-on, on that, on data pre-processing. So maybe it will be helpful if you can share what you've already used to, what you've already learned. So maybe we can like adjust the material to that.
Okay, so if there is no question, before we finish this workshop, Or from Myanmar, do you have any question? No, okay. Okay, if we have no any question, before we finish this workshop, we already clicked the polls in this Zoom. You can find in the bottom there is a polls. We hope you can fulfill the polls before you leave this meeting. Okay, it's only 7 questions, so I think it can be done in 1 or 2 minutes. And we want to say thank you for the trainers, especially BPS Indonesia, for preparing this workshop and as well as the materials. We know that it's a very big effort, especially in this year. Also, you have the population census, so it must be very challenging to prepare this workshop. And thank you also for the participant from IMS that already participated in this workshop. I also want to remind you that this is only the end of the section for the part 1, and there will be a second and third workshop for this training. Okay, so is anyone also can see the polls except the Miss Dwi Puspitasari?
I can see the polls too.
Oh, you also cannot? Okay, wait 1 minute. So about Pak Heru, do you can see the poll? Oh, sorry. I forgot to click the launch polling. I already just clicked the launch polling. Can you see it now? The polls in the bottom. Okay, so please take 1 or 2 minutes to fulfill the polls. It's only 7 questions. One minute. We still have 1 minute again. Okay, is everyone already submit the polling? Baik, Bapak Heru. Okay, 1 minute again, I think, because there are some participants still filling in the polls. We already have the polling from Brunei, Indonesia, Philippines, Singapore. I think we have the participant from Thailand as well. Mr. Tidarat, can you please fulfill the polls? Okay. So I think it's finished. I will end the polling. Okay, so the polls is already finished. Thank you very much. I also already shared the poll result. Maybe BPS also can see the result. I think in the last session, BPS want to give some quiz, right?
Right, if we have time.
Yeah, I think we still have 5 to 10 minutes.
Okay, if we still have time, then maybe like this is more like just a game. Actually, wait.
Okay.
Wait. I'm going to prepare this. Okay, so I've copied the link to the chat box. Maybe you can access that through your browser.
Okay.
Yeah, this is like we are using quizzes. So basically we have 10 questions regarding what we have explained. And yeah, maybe just, it's just like a simple quiz to test your understanding.
Okay.
Yeah.
So how many minutes we have to fulfill the quiz?
For each question, I provided 20 seconds, but if you've like can submit your answer before that, then that's better.
Okay.
Each one of you can like perform it in your own pace. Okay,
Okay.
so if you see my screen, there are already the 3 participants.
Okay.
Yeah, hopefully all of us.
Okay, let's
can
start.
join. So excluding the one from BPS and ASEAN, there should be like around 9 maybe. Or I don't know.
Okay.
Yeah, or maybe 7 or 8. Maybe. Shall we wait a bit more or shall we start?
Okay, I think let's wait. Brunei, can you join please the quiz? The link is in the chat box.
You can just click it and it will open in your browser.
Okay, I think we can start.
Okay.
Yeah, Pak Hairul already joined.
Okay. Okay, so I'm going to start it.
Hmm.
And good luck.
Okay. Okay, focus to your browser, right? Not to the Zoom.
Yeah.
Right? Okay.
Yeah, don't see my screen. Okay.
There is a question in chat box.
Yeah. Wait. Or do you want to share screen, Rosalinda, maybe? Maybe we can try to help. Because supposedly it appears, oh yeah. Sometimes maybe it's connection issue. Okay. Yeah, so it's kind of interesting because the leaderboard keeps on changing. And if we see from the questions, the accuracy is increasing. Okay, so 6 from 7 is done. We're waiting for one more. And we can see like the accuracy for each question here. And yeah. Bit more. Okay, so it's done. And the third one is Mr. Fatur. The second one is Mr. or Mrs. Narlin. And the first one, yeah, the first one is Miss Rosalinda. Okay, so yeah, basically that's the quiz. Thank you for participating. And as you've seen in your own screen, after you've finished the quiz, there will be like, not an explanation, it'll be like just like the correct answer for that. This is not showing in this one, but it should be showing in your screen, like what is the correct answer for each question. And yeah, like this one. Okay, but maybe we won't have time to discuss each of that in detail, but hopefully you can gain a bit more understanding from that. Back to you, Mr. Rian.
Okay, thank you very much. So I think it's already time for the Friday Flyer also. So thank you for the trainers and participants, and we hope we can continue to the next session of this workshop. See you.
Thank you all. Thank you. Yes.
Thank you. See you.
Thank you, everyone.
See you.
Thank you. Thank you.